So this video is really about techniques for macro writing. I was in the midst of writing a macro and figured recording a video might be useful to people. So what I'm trying to build is a way to extend or to allow people to write macros or generate a macro that extends defsc, which is a macro in Fulcro for declaring a component. So the idea, and we were having a chat about it a bit earlier, but the idea is to take something like a defsc where you would normally have to write the component, the props, and in the map here you could say protocols, static, and then say my thing, this protocol up here on line 7, and then you can define methods. And that's already supported in defsc. But what if you just wanted to be able to say method 1 and use this symbol that was already up here implicitly, that sort of thing. That would need to be rewritten from what you've written there. And of course this one's not assuming static on this particular protocol because I'm using this. But have that no-arg method rewritten to the appropriate protocol thing, just matching the keyword to a method symbol, and then inserting the required single argument for this. And for example, if the thing had multiple arguments, let's say method 1 had 2 more arguments, here you would specify them like that, and then whatever symbols you used, like S and T, would end up down here, so that the body that you used would end up with the right pass through. So it's not really that big of a deal of a thing to do, but it's certainly a lot nicer to be able to write key lambda and have that turn into this whole mess. So that's what I'm building. So the way I do this in macros is I look at the individual pieces that I have to build, and I'm interested in writing things that can emit those pieces. So for example, one of the things I need to do is I need to take an option out of here and turn it into something that looks like something else. So I'm actually writing tests that take a literal quoted form, right? So this would be an internal macro function for building this thing. So I'm going to pass it the environment that the macro picked up for error message reporting. Whatever symbols being used for this in the macro, I'm going to pass through explicitly to this function as just the symbol. Whatever method we're trying to implement, again, just going to pass it through as a symbol. Whatever argument list this particular method requires, and I can pick those up off the protocol. And then what the user's going to write. So the user's going to write this without this, and then what it should emit. And so I can run that test, and I can see that this function does the right thing. And so then I can go through and write. And in this particular case, I'm using a pre-built function that Fulcro already had called replace and validate function that does this operation for me. And I can just tell it how many of the arguments are user arguments. So I can take the required args that came from the protocol and say, okay, we don't need one of those because we're going to throw this argument list in front. And then I could do an additional test, say on a different protocol. All right, let's do one on this hierarchy. And actually for this particular call, or the method, right, I don't actually need the protocol for this because at this level of testing, I'm assuming I've already pulled the method out of the protocol. So for this test, I'm going to test that it supports a function with higher arity. And this is really testing a function that Fulcro's already tested. But the arguments I pass here are the required args, so this a, b, what the user writes, well, let's say that's x, y, right? So this is what the protocol is going to tell me. This is what the user is going to write in defsc. And then, of course, we want to make sure that that passes through this test. So I should see method 1. I should see whatever this symbol is explicitly, but then I should also see the user arguments of x and y, and then the user arguments of x and y there. So run the test, checks out. Okay, so now I've got that piece. So I've got a piece of code now that can take something they've written like that and turn it into something that looks like that. So the next step is see that, you know, it can do that for the next step. So this next test I'm writing has to do with going through and if I've got more than one method in a protocol, making sure that they all get turned into things. So the first thing I'm going to do, though, is say something about when do you get syntax errors. And if you're writing a macro that emits to Clojurescript, so the Clojure is going to be running as part of the Clojurescript compiler, you can actually throw an analyzer error with the environment, and you can merge the metadata from whatever form you're currently processing from the forms you received into the macro, and that'll get you line and column number information on that specific form. So say, for example, it's you've picked up this map, right, and you're currently working on this form. If you merge the metadata of that form, that literal, you know, list of symbol fn, vector of symbol st, if you pick the metadata off that, that'll have the line and column number of that thing. So you can give an error message that points right to that thing. You merge the metadata of that form in with the environment. This is the and e and v that you pull off the macro. I'm writing these just as plain Clojure functions to do my transforms. So if I throw this kind of error and I can put an error message on it, then that'll give a really nice compiler error to the user of the macro, pointing right to where they made their mistake. So what I want to do is say I'm going to report an error if the user fails to provide one of the protocol methods. So if I try to morph something that says, and I'm pulling the methods off the signatures of my thing. So protocols have a sigs field. The protocols are just a map. It just defines a map, literally. I could show you this in the REPL. So the sigs of my thing, or if I just look at my thing, you see that it's a map on this, on interface. It literally just has all the information about the protocol in it. So I can pull that out. Now I'm assuming these protocols are going to have to be defined in a CLJ-C file so that the macro will be able to see them as well as the Clojurescript side. So it's a little tricky when you're writing macros because they run in the compiler on the Clojure JVM. So you have to like do some interesting flips. So I've pulled the method, so this is going to have those two signatures in it. Which you can see down here again. Method 1 and method 2. So if the user just provides an options map, that's what this argument is to this guy, the incoming options map. If it doesn't contain both of them, then I want to see it complain that there's a required method 2. And if they use a multi-arity, so you can define a protocol where a method has multiple arities. I'm not writing this extender to allow that just yet, and somebody might do it in the future, but at the moment, if you do this, it's actually not going to do what you expect. So I want to throw an error on that too and just tell you, hey, I can't support that yet. So it reports an error if the protocol has multi-arity protocol methods, and so the extended defsc does not support multi-arity is essentially what this method error message is, and I'm just being a little lazy. So for on all the tests, you can actually see right, and no failures, no errors. Unfortunately, when I use the assertions macro to get these nice throws clauses from Fulcro spec, the IDE test runner doesn't quite pick up the successes correctly, but it doesn't pick them up as errors either. Okay, so there's my two problem cases. So now I want to see, correctly morphs the methods to, or the options to methods. So I'm going to pick this guy up, and here I'm going to do the regular methods again, and here that's going to be method 1. And method 2, and this should not throw. This should give me back a literal form, and I can run this and see what I'm actually getting back. So I'm getting back method 1 and method 2, so that actually looks right. So I'm going to get back, let's do this as a regular quote, not a syntax quote. I don't want it throwing symbols in on me. So I should end up with method 1, which takes the this sim and calls boo1, and I should also get method 2 with the this sim, which calls foo2. All right, passing. Okay, so now I've got my two supporting functions to help me build out this syntactic modification. And so this guy's tested, this guy's tested. I've got a resolve, an extended resolve that I did here that I'm hoping will work, so I haven't tested that. So let's try out the resolve. I don't use the main resolve stuff all that often, so let's actually, I think we can probably just say assertions. Okay, so if we say dext resolve star some environment that we don't care about, some input form we don't care about, right? Because we're just trying to resolve this final symbol, and then this should throw some sort of regex, and let's put some garbage in there so we get a failure, and we can see it down here. So expected an error to be thrown, but nothing was thrown. Okay, so I expected resolve to throw an exception. I'm catching around it, and it's not. So so this is going to be the actual value, and let's make that an if let. Okay. Oops. Cannot resolve. Yeah, we did get it. It's a little hard to read these sometimes because other things that are happening are, like that caused a test to pass, but for some reason we're also getting stuff as output. Am I logging? I'm not logging on that, am I? No, not printing in any way. Okay, well, I'm not sure why the testing system is giving me the additional crap, but so I have one failure. I'm mainly looking at the numbers down here because the output is hard to see, and I'm not getting green markers. But I'm going to say cannot resolve undefined, and now I get no failures when I run the tests. Okay, so, and then I should say resolve star gives back the real item So here, if I try to resolve the symbol my thing fully qualified, I should get back my thing. Oops, but I don't. What does resolve give back? Same as nsResolve. Oh, returns the var. So I don't want the var. I want to, oops, thread that through, what is it, get var? Or var get? Yeah, that's what I want. There we go. Now my test is passing. Go back over there and show you that it's passing. So it's good that I tested that. I actually hadn't written it correctly. Okay, so now there's my extensions test. Okay, so now report's doing its job correctly because I'm testing it indirectly just by seeing the throws that I'm getting. Resolve is tested, this guy's tested, that guy's tested. So now I'm down to a function I was writing that's supposed to essentially emit the next piece. So if I go and show you this test, this actual bit here. And really all this is a preamble that's got the protocol name as whatever symbol you're going to define. So I haven't shown the portion of the syntax we're going to actually use as the kind of library author of a new kind of defsc, but we're probably going to do something like extend defsc with the protocol. We probably want to make this look like something that IDEs already understand so we can get IDE recognition. So there's going to be some syntax here where we say something like, the thing we want to extend and whether or not it's static, something like that. Extended defsc as defsc router, that sort of thing. So I'm going to make a defsc router thing, and it's going to need this protocol. True, we're probably going to want to be able to do multiple, so this is probably a list of protocols. And because some of them might be static and some of them might not, we might want something like that. I'm not sure yet exactly what this is going to look like, but this is the information we're going to have as input. We're going to have some symbol they're going to be able to use to get support that turns this into this. But really I just need to know what protocols and whether or not those protocols should have static in them. So for a given section, I'm going to need that preamble and then the refined methods. So I've already tested this function that morphs my options. If they indicate via an option here, because this again is just a helper function internal to the thing I'm building. If they say it's going to be static, then I need to include a static symbol and then the protocol symbol, otherwise just the protocol symbol. And I can tilde patch those into the beginning. That'll be my preamble, and then the refined methods. And then resolve star is going to give me back the actual protocol, because remember, when I'm building a macro, these helper functions will be handed the unevaluated form. So I'm going to literally get a symbol for this, literally a symbol for the protocol that I'm going to have to resolve if I want to read the protocol and understand it. The options map is going to be an unevaluated map. I mean, it's going to be a map, but the values in it are just going to be literal forms, and then this can be a true false that the macro passes in based on parameters it had. So we're doing a really advanced thing here. We're building a macro that builds macros. Okay, so let's try out making a test for that. And same sort of thing, we can probably just start off with some assertions. Okay, so I guess, emits the correct forms for embedding in defsc protocols option. Okay. So emit protocol is going to take an environment that I don't, it's just a map of data about where you're at and stuff for error messages. The this sim, we can just make one up. T, that's fine, it's nice and short. The protocol symbol, so here we really need it to be, the thing we're working on. As a symbol, the user's going to have to make sure that's resolved to a real thing, like at least is, the macro can pick it up with the current namespace aliases and stuff, and it'll end up with the right thing. So we'll backtick quote it here. The incoming defsc options. So with my thing, we're going to have method 1, method 2. So they must have said it'll look same just like this thing up here we had earlier. And then static. Let's see. For embedding a static protocol in the defsc protocols options. And then we want one for the non-static. All right, and this one, again, I'm checking to see that it's actually outputting the correct closure for a macro's interpretation of this. So my actual was static, fully qualified, symbol, method. That's actually exactly right. So sometimes you can manage to copy out of these dialogues and not have to type all that mess. You just eyeball it and see if it's right. Method 1 t boo, method 2 t. All right, so that one looks right. So now I only have one failure, and it's got the static in it. And this guy, well, this guy should be the same thing, just without static, right? Yeah, if I could type. All right, passing tests. Okay, so now I have a transform function that can take the forms I've picked up out of a defsc options map. And of course, this can have other crap in it, right? They could have an ident in there. I can even do that, and it still won't break things. The ident could be anything. The query could be, a literal vector of some garbage. Like those things are ignored, so it's not going to hurt anything for those to be there. I could write an explicit test for that, but these are maps. That's just like kind of a normal thing in Clojure, so I'm not going to bother saying it. Okay, so now I'm ready to write the macro that emits the macro. Fun. Okay, so oh wait, I need something that probably composes these together based on the other guy. All right, well, I'm going to continue that outside of the video. This video is probably getting long enough as it is, but you see the basic approach I use to building macros. Build just regular Clojure functions, test them as regular Clojure functions that just morph what you're going to get from a macro into what syntax you would expect to be emitted for use by the real compiler in the real code.